Okay, here is a video on Unit 2, Activity 1, the lab assignment. And it's based on exponential functions and comparing them to linear ones. So let's go ahead and do 1 and 2. Maybe we'll do a couple pages for this video. Let's read number 1 real quick. And it says on the CIA World Face, that's supposed to be Facebook or Factbook. No, that's correct. Factbook website. It's going to say that the world population increases by about 1% each year. And I guess you've read the rest. This means that the population multiplies by 1.01 each year. So if that is the case, as soon as they start talking about multiplying by a percentage or same percentage rate or constant ratio, so to speak, you know you're into a little bit of review if we've forgotten an exponential situation. Now you can put an X here or you can do it this way. Because a lot of times we have time in our exponential spot. Remember, if we're reviewing, the A is the initial value, the B is the growth factor or the decay factor. And remember that decay factor here, that B, is governed by 100% plus the rate. So in other words, if B is greater than 0, excuse me, not 0, I misspoke, greater than 1, so don't hold me to that one, your function is going to be increasing, and if B is less than 1, you're going to be decreasing. All right? So notice they're already telling you that the function is increasing and the rate by which it's increasing. So if that's all you had and you already know it's exponential, B would be increasing by 0.01, excuse me, 1 plus the rate would be 0.01 written as a decimal, or your B would be 1.01. Now we're a little ahead in the game in the fact that I'm teaching you ahead of time how to solve for this growth factor, decay factor. So we already know it's 1.01 and that it's increasing. And they gave you the number right here to make things even easier. So a lot of times it won't be this easy. But in this case, we don't have to work too hard. There are currently 7 billion people in the world. So remember, that's your initial value. So your answer is going to be 7 times the quantity, 1.01 to the t, where 7 is in billion. So if you're just going to use 7, that's fine. You don't need to write out 7 billion. But remember your answer, you have to say y is population in billions. Okay. Also, if I was going to do it, t is equal to time. And again, I'm having a problem with my stylus, so I apologize. So maybe just bear with me. So once you have that model, if you wanted to use the model to predict the world's population in 2035, let's see when this model starts at. So it says the world population increases by 1 per each year. This means there are so if there's 7 billion now in 2021, all we have to do is a little subtraction there. So that's 14 years later. So you use your model to predict 14 years later. So what we would do, 7 times 1.01 to the power of 14. And if we do that, you're going to end up with, hopefully get your calculators out, 7 times the quantity, let's see, 1.01 to the 14th power is 1.149 and a bunch of other decimals. Now I'm going to leave all the other decimals in my calculator, which means you might, if you only plug in 1.149, you'll get a different answer slightly. But if I just times that number with all the stuff behind it, 8.046. Oh, 463. I could keep going. But that's going to be your population in billions. Okay? So that's how you do number 1. And keep in mind, exponential functions have a constant percent change or a constant ratio. Linear functions, so this has a constant ratio. Or a constant multiple, whatever you want to do, constant ratio, I always say. And this has a constant average rate of change. That little triangle means change. So please don't get misled by the fact that I'm using the rate in 2 different terms. The rate, when you're talking about it as terms of a growth factor, is built in to the actual growth factor, that R right here that we've been talking about. But the rate of change is really just the slope, which you should be okay with y2 minus y1 over x2 minus x1. All right? So if you had to complete that table, for instance, let's go ahead and see if I can get my cursor working here. And the directions were to complete the table. Well, you can probably do a lot of that, gosh, just by doing a little mental math. And let's go ahead and do this one, the linear one in blue. But if I were to plug in 0 into this function, you'd have 3 times 0 plus 2 would be 2. And then all I'm doing is this function in my head, 3 times 1 plus 2 for the next one, which would be 5. And then if I did y equals 3 times 2 plus 2, what is that, 7? So notice I'm increasing by 3 every time, and you can fill out your chart that way. Now on the midterm or the test, you might be asked, what do the constants 2 and 3 represent? 3 is the average rate of change. Sorry, I don't even know how to spell yet. Which means the slope. And 2 would be the y-intercept. All right, so hopefully if you've already done this, this is matching your work. Now over in the other one, if you were asked to complete the table in exponential form, now again, I'm just going to plug in numbers, and let's do this one in green. But if I had y equals 3 times 2 to the 0, remember anything to the 0 is always 1, so 1 times 3 would be 3. And then after that, 3 times 2 to the first, well, that's just going to be 6. And let's do another one, 3 times 2 squared. See if you can see the pattern. So 4 times 3 is going to be 12. So every time that thing's doubling like we've done in previous examples. And in this case, when I ask you on a midterm, if it's just numbers, you can say 3 is the y-intercept, or the initial value. See if I can fix my stylist. I'm sorry. It just does that sometimes. And, let's see. 2 is the constant multiple, or called the growth factor. Okay? So, as we keep munching up these questions, let's go ahead and do the next part of this thing where you're going to compare linear functions and exponential again. So let's go ahead back to blue. Look at part 1 here. Write an example of a function that has increasing and has a y-intercept of 5. So remember, there's my function. So all I have to do to be increasing is have that slope. It needs to be positive anything. So in other words, I could say y equals 2x plus 5 because that's the y-intercept. Or you could say 3x plus 5 or 2/3 x plus 5. It does not matter. That 2 here can be anything as long as it's positive. And that is a linear function that's increasing and has a y-intercept of 5. Now, in the exponential case, and this is why this lab's pretty good, if you wanted to do an exponential form, remember that's just ab to the t, or x, your pick. Now the y-intercept of 5, in this case, needs to go right there in the front. And the reason is that's just the initial value, remember. And if it's increasing, the only stipulation is that b has to be greater than 1 to increase. So in this case, I can say 1.24, 1.01. I could do 4/3, which is just 1.3. It does not matter as long as b there is bigger than 1, like we stated. So notice that's the difference. To increase for a linear function, m has to be a positive anything. And to be increasing for an exponential function, b just has to be greater than 1. So there's two different things that make that each function increase. Now, likewise, if we talk about the other version of that, if you wanted a linear function that was decreasing, then you could say m needs to be negative. And again, you could do any negative you wanted. And I'm assuming you're okay with me just putting what? Negative, I'll do the same number, but negative 2x plus, notice again, the y-intercept goes, and that's 12. And then you can have a negative slope in there anywhere you need it. Now let's switch gears back to exponential functions. If you wanted a decreasing exponential function, the y-intercept goes first. Remember, that's the initial value. And to be decreasing, your b just needs to be less than 1. So hopefully you're catching on. It doesn't matter if it's 0.93, 0.2, 1/2. As long as the whole value or decimal value is less than 1, you're okay. Is that okay? Now going forward here to the second page, and then we'll stop this video. I don't know how many more questions there are, a couple. Let's see what 4 says. Check your 4 equations using your calculator to make a table for each function. Remember to verify each one from problem 3 on page 105. We're going to go ahead, and we don't have page 105 with us, so we'll have to go ahead and just negate that problem. Okay, but if you're going to, as I'm talking myself through this, I'm just now seeing this. Let's see, remember blah, 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 blah. Okay, so let's go ahead and let's say you don't, let's say 4 is a question. And you, or even if it wasn't, for number 5, if you needed to come up with the functions, take a look at 4 and it's going in half every time. So if it's going in half every time, 4 is going down to 2, going down to 1, your function here for the first one, notice I put it in green to be exponential, will be 4, and you're going to go in a half every time. So there's your exponential function. This one is exponential, especially if you've already done this for a lab and are checking your answers with me right now. Then I'm going to assume this one's linear. And if that one's linear, my y-intercept is going to be 1. So y is going to equal something x plus 1. Notice all I have to do is fill in the slope there. And here I'm going down, right, by 25 every time, 0.25. So minus 25x every time. So we just found our 2 equations, even though we can't refer to that problem. And the only reason why I wanted to do that, sorry, let me scroll back down here. My computer's just jumping. Is so that we can answer part B. Well, I guess this is find the equation for each table. So we already did it and we already talked through it. So we're good. All right, last part. Problem 6. Here we go. Let's do it in blue. A linear function is increasing if its slope is, what do you think? Positive. And it's decreasing if its slope is negative. Notice I'm still using blue for linear functions. And for exponential, the exponential function is increasing if the growth factor is bigger than 1. Let me draw that one more time with my stylus. I think I'm learning how to fix it here. So b is greater than 1. And it's decreasing if it's less than 1. Okay, so those first 2 pages. Next video, I'll do the next 2. Hopefully that helps, and good job.